I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about why sea state realizations are so important in ship motion analysis, mooring analysis, and any kind of dynamic analysis of a floating system. So normally when we talk about sea states, it's pretty common to characterize the ocean's condition, what the waves look like in terms of a frequency spectrum. This basically gives you an idea of how much energy there is at different frequencies of wave motion at that point in time. The problem is it doesn't really give you an idea of what's actually happening in the sense of a time domain. And it doesn't have any obvious information about the phases of the energy components of those. Spectrums are great, they're really useful, we need them, but they don't give you an exact instance of what's happening at that time. And that's what a sea state realization is. A sea state realization is a time sequence of what the waves actually look like in that characterization. So they have the same significant wave height, they have the same peak period as the spectrum, but they're a time series of what's actually happening. So just to visualize that, I have three different sea states here. Now, they're all exactly the same. Every single one of them has the same significant wave height. They have the same peak period, but as we play them from the start, to the finish here, they just have a completely different look and feel to them in terms of how they evolve in the time domain here. So it doesn't really matter what it is, but it happens to be a 9 meter 13 seconds a significant wave height condition. And I colored them, well, for fun, but basically to just show that they're the same yet completely different evolutions in time of what the system looks like. So when it comes to software like ProteusDS, why is that important? Why do we care about these things? Why they're important is it's really important to get a robust characterization of the motion of the system that you have. You want to make sure you're capturing extreme motions, that is to say, or extreme loads in your mooring system. And one way to do that is by checking what happens in a variety of different sea state realizations to make sure you've really got a reliable indication of what those extremes look like. And there are other effects like that might affect the means, the mean values and standard deviation of values. So in any case, there's no rhyme or reason. It's really hard to know intuitively like how many realizations you should use on a project. That's another story. But being aware that there are these differences is really important, a really important first step. And using multiple realizations is definitely a crucial aspect of using software similar to ProteusDS. Where might you find something like that? Well, when I ran these basic cases that really they don't have anything in them, you can see things like the wave seed and ProteusDS simulation toolbox here. And this is a number that initializes the random number generator that's used to make the phase offsets for the waves. And in another tool like ShipMo3D and the ShipMo3D toolset for ship motions related work, you'll see under build seaway, there's a number here, wave phase seed number, which performs a very similar function. And then that'll come into play in the time domain maneuvering analysis application FreeMo and time series from RAO, kinematically resolving a time series of ship motion from an RAO and the resulting sea state. So just some examples there. Of course, you want to check multiple realizations and just see what happens to, your system and make sure you're keeping an eye on the results that you get out of it. That's all for now. Thanks for watching.